answers to see if they're the same? See, like you haven't even checked, and you're like, oh, I have questions on 9, 10, 11, and 12. No, check your work. For those of us who didn't get it done, look at it now, ask questions about, hey, are these, why did you do it that way? So notice I didn't show how I got there. All I did was show you the final answer. So if you did not get that final answer, you should be like, ooh, hold up, Mr. Kinney, why did I get this incorrect? So any questions off of 9, 10, 11, or 12? And if you didn't do the homework last night, if you look at it and you're like, I don't understand how you got there, let me know. Where's the other page, dude?
Okay, so my only difference with the 10 and 11 is instead of doing the line over each thing, I just did divide by 7.
Okay.
Divide by x.
So you did this?
No, I understand my mistake now.
That's what you did?
I understand my mistake now, but I get it.
I know, but is that how you wrote it?
Yes.
Technically, that's almost right. Does anyone know what I could do to this to make it equivalent to this right here?
If my brain was working right now, yes, but now it's not. This doesn't know.
Come on, I need y'all thinking about this because this is something that you could do. So Peyton said he didn't divide by 7 with the fraction. He just put the division by 7 here at the end. But what is missing from this that could make it equivalent to this idea down here?
Well, look, if you want me to screw it up and say something wrong, maybe Shelby will call it range like 2 seconds later.
You could get salty some more, or you could just think about it and try to come up with an answer and we can talk about it.
Ooh, that's
I want y'all to notice, this is only dividing 6 by 7. Is this only dividing the 6 by the 7?
Yes.
Right here, I'm only dividing 6 by 7. Y minus 6 by 7. What could I do here to put the y minus 6 together? Yep. Good job, Corell. Look at Corell getting involved this year. Someone already on a better foot than last year. Let's go.
Not the homework part, though.
Not the homework part. We'll get there, right?
Yes, sir.
All right. So notice you can do that, but I would highly recommend, if you're looking at number 11, right, y equals 7m plus 6, we want to solve for m, right? So we subtract by 6, y minus 6 equals 7m because 6 minus 6 is 0. Then you just show the division like that, right, Peyton? And so 7 divided by 7 is 1. So m is equal to y minus 6 divided by 7. Any other questions before we move on? And also, again, I want to remind you, you need to show your work. Because usually if you just have an answer there, that means you went online or you got someone else to help you with it. You don't actually understand it. You need to show your work and you need to ask questions if you don't know how to do stuff.
If I would have got online, I would have got them all for.
Possibly. I don't know if you can do literal equations online with photomath or something like that. But again, that's not going to help you when it comes to quizzes and tests, so that doesn't help at all. I feel like we're missing some phones. Let's see. No, Kelsey, yours isn't 25? Mm-hmm. Okay. Devin, you don't have yours today? Corell, you don't bring yours to school?
Sure.
And Emery's not here today. Cool. Alright, let's move on then if there are no questions at this point. Going once, going twice. Sold. Okay. What?
You always tell me I all got those every single question right.
Hey.
With correct justification.
I didn't do it.
Okay. And nobody else has any questions.
I love how Peyton's calling all of y'all out.
I'm
Straight
sorry, okay? But he's already told me that I'm pretty good at this, okay? So if I'm good at this and I'm screwing up and I'm making mistakes, unless y'all are straight A in this class, no way that y'all got that exactly correct with exact correct justification 6 out of 6.
Alright.
I mean, Is Peyton technically wrong there? I would say
No.
no. However, I would say you could have your delivery a little bit nicer on that side, Peyton. But at the same time, like, his frustration's a little justified, guys. Like,
Okay, none of y'all are Einstein, okay? So
hey,
y'all
whoa,
are
you don't need to come at him like that. What I would say is,
'Cause it'd be
if
nice.
you want to grow and get better, right? We're not going to worry about comparing ourselves to Einstein. If you want to grow and get better, Peyton is correct. You need to ask the questions when you are confused or you have mistakes. Questions are not a bad thing, they're a good thing. Mistakes are not a bad thing, they are a good thing. Because the person who asks the most questions learns the most, and the person who learns from their mistakes grows the most. So, you need to make a decision. I'm going to sit here silently and struggle, or am I going to ask the questions to fix my misunderstandings? Here's our agenda for the day. We're going to look at the objectives. We're probably just going to look at number 9's justifications. And then we'll do number 10's justification tomorrow so that we can get a little bit of practice in before we have a quick understanding check before we wrap the day up. Okay? So, Corell, you read yesterday, right? No? Who read yesterday? Shelby?
I read on
Monday?
I don't know, I don't think I did.
Layla, I think you've read before, haven't you? And Kelsey? So Peyton, oh, you haven't read? Kelsey, can you read the first objective for us then?
I can solve an equation for a specified variable in an intentional order of the inverse operation.
Okay, and so there can be more than one variable and you need to know which one you're solving for. And the intentional order that we're talking about here with the inverse operations is you actually typically want to start with whatever operation is being done last, right? You want to start towards the end, start at the end there, undo that, and then work towards the variable you're trying to find. And then well actually I don't need to read this. Jalea, can you read the second objective for us?
I can justify the
Solution?
solution process with inverse operation that creates the
Identity?
elements in the
Properties?
properties of class.
There you go. What are the identity elements?
Zero.
Times 1 and plus 0. And so when we use our inverses, we're going to create either multiplying by 1 or adding 0. And that's useful and powerful, right? But we do need to keep the properties of equality in mind, because when I use those inverses, whatever I do to one side of the equation, gotta do to the other, right? These are the basic tenets of solving equations that we've discussed. And so last night I asked you to justify the solution process for numbers 9 and 10. We worked both 9 and 10 out, correct?
Yeah.
Okay, so I was just asking you to justify both of those last night. So here's the work for number 9. Let's talk about the justification process together and go through what you said. We do have the understanding check today, so I need 25 minutes left at the end of class, so till 1. So we have until 12:35, okay? The quicker we get through number 9, what?
You're taking our enrichment time?
12:35 to 1,
Oh, okay.
and then you have 1 to 1:25.
Oh, okay.
There you go. That's what I was saying. We'll stop at 12:35, so you can take your understanding check. Then we'll, yeah, good?
A test?
It's
Okay.
not a test.
Oh, please.
If you, yeah, what's the difference between a quiz and an understanding check?
Understanding things, see where you're at.
Yeah, an understanding check is more to see where you're at, to see how well you understand it. This is also why when you take a test later, if you do better on the test than you did on the understanding check, I let the test grade replace the understanding check grade, right? I don't care about when you learn it as long as you learn it, which is why you also have the options of retest and things like that. So it's more of an understanding check than just a straight quiz. It's trying to check to see how well you understand what is happening so that you can learn from your mistakes and grow and get better. Can you throw on the back counter for me, please? Thank you, sir. Okay, so I think we already justified number 1 together yesterday, right? Did we all do that together? I think so. And so why did we add d to both sides of that equation? It's the inverse of the last thing being done, right?
So I use the inverse because it is the last thing being done to get rid of the d.
right? There you go. So when I look at that x that I'm solving for, the first thing being done to x is multiplying by a, then we are adding that b, then, and then all of that is being, there we go, right? So the last thing being done on the left-hand side of that equation is minus d, so we added d to both sides. For that property of equality, it was also the inverse, and that inverse created what number? 0, right? So that's how we got ax plus b just divided by c. So this is what we're going to pick up in this second step, trying to justify it. So Shelby, what did you say for your justification on number 2?
I multiplied by c because it's the inverse of dividing by c, and then both sides to b.
So I multiplied by c because multiplication is the inverse. Is that what you said? Inverse of what? Okay, so it's the inverse of dividing by c. Then what did you say after that?
Net to both sides to b.
Ah.
This is the equation.
And I multiplied by c on both sides to keep the equation equal. Julia, what do you think of that justification? Does that cover everything that we need here? No? Why not? You said no. Do you know why you said no, or are you just saying no? So notice we're only looking here. So let's break it down. Did we multiply by c on both sides? Okay? So then let's think about it now. So we got to multiply by c because multiplication is the inverse of division, right? So we had division, so we multiply by c. So is that a true statement that multiplication is the inverse of division? And what do we know about inverses? They do what to each other? Cancel each other out. Specifically in this case, c divided by c is 1. Right? And that's why 1 times ax plus b is just that ax plus b.
C.
Okay? And did she multiply by c on both sides of the equation?
Yes.
And does that keep the equation equal? Okay, why do we know that keeps the equation equal? By the properties of equality, right? So the only other thing I would really maybe add here is by the property of equality, right? But that's what you're saying here. To keep the equation equal, that's to do the property of equality. So, Julia, do you think that's enough, or do we need to add something else? Does that cover everything?
Well, this quietness is reassuring.
Oh, Julia's thinking it's okay. Okay, we cover everything in this step right here. Notice we haven't talked about the other steps. Have we covered everything here? So are we good? Yeah. Okay. Kelsey, what'd you put
Yes.
for this third step here?
Where?
This
I
one.
I subtracted b because it's the inverse of adding b.
Okay, so I subtracted.
To keep the equation equal.
Okay, I subtracted b because that is the inverse of addition. By the way, I do want to point this out. Like, this is another way you could say this. Please notice when you do b minus b, what number are you creating? You're creating 0, right? Anything minus itself is 0. So you can also explain, hey, that inverse is creating the identity of plus 0. Okay, so you can talk about that as well. So that is the inverse of addition, right? So creating the additive identity. That's another way that you could say it, and that's why I put it in parentheses. It's just an alternate way. What am I missing? I think you said it earlier.
Who?
You, Kelsey. What am I missing?
Oh, properties of equality.
And I subtracted from both sides. By the way, I'm writing, but I don't hear all of us writing. This might be a useful thing to have written down so that you might be able to use it to study later and things like that. This full justification, why everything is happening. Because if you can't explain it, you don't understand it quite as well as you think you do. You need to be able to explain these things.
I'm gonna start using regular pepperoni test.
Say that one more time.
I'm gonna start using regular pepperoni tests so I can use longer justifications. Cause you barely give us room to justify, so I'm just gonna use regular paper.
So like just staple copy paper to it?
Yes.
That's fine. Yeah, if you ever want more room, you can pull out an extra sheet of notebook paper or a piece of copy paper, whatever you want. So Peyton, actually I'll wait a second for those who are copying that down. Alright, Peyton, what was the last thing we had to do here in this step?
I divided both sides by A because I had to use the inverse to cancel it out.
So dividing by A
To cancel out.
because that cancels out,
Also I did to both sides because
hold on, cancels out what?
it cancels out the A.
Okay, what's happening with that A though?
Cancels out the multiplication.
And I do want to point something out. When you say it cancels out, what do you mean it's really doing?
I mean, it's getting rid of it. It's gone. It's not there. It's
Zero.
Not 0,
One.
1. It's not that it's just everything is gone. It's creating a 1, and what's 1 times x?
it's going by A.
So dividing by A, because that cancels out multiplying by A, right? That's creating multiplication by 1. And we did that to both sides. You said by the properties of equality?
Yes.
Which property of equality are you using there?
Divided.
Division.
Yeah. Yes.
Just the division property of equality. So we want to notice all of that. But we do need to recognize and ask this question, why this order?
You wanna do the
Right, so we do want to indicate somehow that we are undoing the last operation.
You could have done it differently,
There are other ways, but this is the order that we have chosen to use here, just because so that we all have the same answer, right? So we're undoing the last operation applied to the desired variable or specified variable. It's an important detail. Okay.
Why is it that you went to U of M instead of one prestigious college?
They offered me scholarship. Like they offered me a scholarship that paid for my college, plus gave me a good chunk of change to pay for my books and other things as well.
But you had an alumni scholarship, right?
That was one of the scholarships they gave me. They gave me an alumni, they gave me presidential, they gave me engineering.
You had a presidential. Why didn't you go to somewhere different? Like, if you had a presidential scholarship.
Well, my plan was to eventually get a master's, which I did do. But if you're going to get a master's, your undergrad degree, where you get it doesn't matter a ton. That's honestly the best answer that I can give. Plus, I'd rather come out of my undergrad degree having made money rather than paying a lot of money.
Does it make more sense with the way that you teach math that you go to a more prestigious college?
You'd be surprised at how good the math education department at UA is. They have some of the best math professors there. All right, anybody need me to leave this up here any longer?
So why is it that if you had a school of choice, you go to Stanford?
For my doctoral program, when you go get a doctorate, it actually needs to be or colleges prefer that it is from a place other than where you got your other degrees. So since I've already done all my degrees at UA, it'd be best to do it somewhere else.
But Stanford is very prestigious.
Stanford, yeah. Really quickly, I do want to remind you, we worked through this already yesterday, but someone was asking, okay, how would I justify this step right here? What's a very simple way to justify this squaring right there?
You cancel out the root.
Okay, why would it cancel out the square root? Because they are inverses, right? Like it's all about
It works that way.
No, it's not just that it works out that way. Those are inverses to each other. So when you justify number 10 tonight, or when you check your justification to make sure that what you did was good, hey, that cancels out it's the inverse of the square root. All right. I'm looking for a specific type of question. None of these have it. That's okay. Okay. We're going to talk about two things quickly before you start your understanding check in just a couple minutes. Just because I've seen this tripping students up all day today. Okay. So there are several ways to approach this problem. You could divide by 7 right away. Personally, I wouldn't, because can you easily divide 7 into these two numbers? No. So I'd probably distribute here.
Where are you looking at them?
I made this one up to help you see something. And a lot of students at this point have done a pretty good job of saying, hey, I'm going to add 7. Negative 7 plus 7 is 0. And so this makes sense so far. But here's where they start messing up. They have 7x equals, and so they're dividing by 7. That is legal, technically. But now they have x equals, and they would do 2/7 x plus 15/7. And they stop. Is that a good place to stop?
I mean, you could simplify further.
What are you going to simplify?
2 goes into 15 how many times?
You can't do that.
Well, the 2 and the 15 aren't together. Here's a bigger issue. How am I going to write an equation with x equals another x? We don't usually do that, do we? you don't want an x or a variable on both sides, or the same variable on both sides. If you're solving for x, you need x only on one
So
side.
you have to do 2 divided by 7.
Nope. I do not want an x on its own on the right-hand side. Even if I divide by 2, I get 7 divided by 2x, and what's 2 divided by 2? That's 1, right? But what's 1 times x? It's still x. Did I get rid of that x there? I need that to not become a 1, I need it to become a 0. What could I do to make this 2x become a 0? I could subtract by 2x. We've done this too many times to forget this detail. We did a lot over the last 2 days. What is 2x minus 2x?
X.
I have x. What's anything minus itself? 0. Then 7x minus 2x is, so 5x is equal to 15. Then you would want to divide by 5. And when I do that, now I know what x is.
3x.
Not 3x. What's 5 divided by 5?
1.
1. And 15 divided by 5? So x equals 3, not 3x. X equals 3. Very radically different. You can't get upset about that. Okay, one last detail I want to point out, and this is because it will help you on the very last question, and I've told every class this, and only a handful have remembered. There's 2 different ways to approach number 13. What could I do first on number 13? One strategy is to distribute. So A would equal 7 times 3, y'all.
21.
Now, what am I trying to solve for in number 13?
C.
Z. So what would I now need to do to start solving for Z?
That is a interesting looking Z.
Okay.
Why does that have a line?
21 minus 21? 0. A minus 21?
A minus 21.
It's so that, honestly, I don't draw my 2's like this, but some people draw their 2 like that. And so you put the line through it to indicate it's a Z and not a 2.
Gotcha. It looks like you're canceling it.
Gotcha. And what would be the last thing I need to do to solve for Z? Divide by 3, right? That's the inverse of that multiplication. 3 divided by 3. And so A minus 21 divided by 3 equals Z. But there was something else that I could have done at the beginning. What is that?
You could have, I mean, divided.
Multiply by the reciprocal or divided by 3? Because that division will cancel out that multiplication right away. What is 3 divided by 3?
1.
And so A divided by 3 is equal to Z plus 7. What's the last step I need to do to solve for Z? Minus 7. And so then you get A divided by 3 minus 7 is equal to Z. Are these expressions equivalent?
Yes.
How do you know? This is the part where people have been forgetting this all day. How do you know that they're equivalent?
I mean,
What property does division have that we can apply here?
distributor.
We need to remember that. You can simplify that expression by using your distributive property. A divided by 3 minus 21 divided by 3. What is 21 divided by 3? And so you need to remember that you can use the distributive property with your division to simplify expressions, because that is how you determine if expressions are equivalent. All right, I'm about to pass out your understanding check. Before you put up your stuff for 4.3 though, I need you to note that numbers 15 through 18 is your homework. These numbers that are written in are not there. You need to fix numbers 17 and 18 so they have those numbers written in, the 5, 9, and 6. After that, please clear your desk and you'll have 25 minutes for the understanding check. You have 4.3 with you? We'll bring that up real quick, just so you know where it goes. So go ahead and put, oh, you already have them in there. There's a 5 there and a 9 there.
No, I'm slow.
You can see them?
No, wait.
15 through 18. So remember, if you do better on the test than on the understanding check, then you're golden. So you just need to do what you can and then learn